Hello and welcome to today's class. For this trigonometry class, we're trying to consider the concept of trigonometric ratios of angle. Let's discuss the concept behind trigonometric ratios of angle. From here, when it comes to the study of trigonometric ratio of angle, there are three special angles you need to know. The special angles that you need to know ranges from 30 degrees, 45 degrees, and 60 degrees. These three angles are called the special angle. All right. When it comes to the study of trigonometric ratios of angle, we'll try to prove the sine, cosine, tan of each angles here, right? So at this point here, to prove the expression for the trigonometric ratio of this angle, we'll try out to draw an equilateral triangle, right? So at this point now, let's consider an equilateral triangle of two sides of side 2 units and the right angle isolated triangle, right? So what I'm saying is that let's consider a what there, an equilateral what there triangle, a triangle that has all sides equal. This is equal to this and this. At this point here, let's call this point here point A, point B, and point C. Per se, I just call this point A, B, and C, right? The angle here is 60 degrees. The angle here is 60 degrees. The angle here too is what there? 60 degrees. So for an equilateral triangle, a triangle that has all sides equal, its angle is what there? 60 degree all through. All right. At this point now, I want to understand the concept behind this. Let's try to divide this into two. If I divide this triangle into two, what do I get? This part, let's call this part here. Let's call this part 1. Let's call it part 2. If I draw a part 1, this is what I'll be seeing. Drawing out part 1, I'll be seeing something of this nature. True or false? True. Something of what? Of this nature. Drawing out part 1, I'll be seeing something of this nature. This is B. This is what there? This is point C. Right? This angle 60 degrees. This one here. But I divided this into two. Half of 60 is what there? 30. So I have angle 30 degrees at this point. So let's see this is C. Per se, sorry, there's no point here. Let me call it point P, right? Also, drawing out this for section 1. If I draw this one, I'll be having this. Section 2 too, I'll be having something of this nature for section 2. This 60, angle 60. This C, this A, this is my point A here. This one has no specific name. Let's call it P if you want to, right? This angle here becomes 30 degrees. Why? I divided this into two. So half is 30, 30. So I have this section 2. These are the two diagrams. So we said, by the way, we said each side are what? Of 2 units. 2 units, 2 units. It means that here becomes 2. If I divide it from here to here is 2. Divide it, I'll have 1, 1. So here becomes 1. Here becomes 1. Here is 2. I have 2 here. Right? So this becomes what I have in front of you. So we'll try to pick either section 1 or 2, right, to prove our concept. So let's say I want to pick section 1. For section 1 then, I have a right angle triangle, as in this case. Observe please. The angle here is 60 degrees. Next up, I have the angle here being equal to 30 degrees. We said here should be C. Here should be B. This is 2. This is 1. And there should be what there? There should be P. Of course, here, I know two sides. I know the hypotenuse as 2. I know the adjacent as what? As 1. Let's get opposite. So at this point now, I'll try to get a value for this place here. So let's get the value here by using what the concept of Pythagoras theorem. Right? So at this point there, I'll use the concept of using the concept of what? As theorem. what do I get? We said this becomes 2 squared is equal to 1 squared plus let's call it x plus x squared, right? So at this point here, what's your next task? 2 squared gives 4 is equal to 1 squared gives 1 plus x squared. Take 1 here, I'll have 4 minus 1 being equal to x squared. I can swap this as saying x squared is equal to 4 minus 1 is what? Is 3. Take this square because square root, so x is equal to what there? Root 3. So anyway I see x here, I'll put root 3. The value for x here becomes what there? Becomes root 3. Alright, this becomes what I have in front of you here. Alright, at this point now, let's try to prove some concept. Alright, we said we are trying to prove the sine, cosine, and tan for each angles for 30, 45, and what? 60. Let's consider 30. So for this one, now I'm having only 2 angles. So we can't derive 45 from this one. We can only derive what? 30 and 60. So let's start with, let's consider for 30. Consider angle 30. Consider angle 30 degrees. What do we get? Consider what there? Angle 30 degree. What do we get? From here now, let's get angle 30 degree. Let's start with the sine. For sine, please. What's sine theta? That because of there. What's the expression for sine theta? From the idea of socatoire, I have so, ka, and toi. So what's sine theta? Because what there? Opposite. On what there? Hypotenuse. But my theta here is known. What's that considering? 30 degrees. So I'll have sine 30 here. So it's equal to opposite of hypotenuse, Abi. Now look up, please. Considering angle 30, please. Look up. I'm considering 2 things here, 30 and 60, right? But let's start with what? For 30 first. Don't do 60, do 45. For 30 now, listen up, please. This is angle 30, Abi. If I'm considering angle 30, please, what's my opposite? This place become what there? Opposite, Abi. Because the angle is facing here, because opposite. But if I'm considering angle 60, here because what there? My opposite. But now I'm considering what there? Angle 30. Now listen up. What's my opposite? That because what there? This place, that's PB. So I have PB as my opposite. All over. What's the hypotenuse there? That's BC. I have BC. What's the value for PC? That's 1. All over what there? What's BC? That's 2. So it means that sine 30 degrees is equal to what there? 1 over 2. Note this man. Very important. Alright, this for sine, please. Let's do for cos 30. Cos 30 degrees. What will it give us, please? What's cos, please? Cos is what? Adjacent by what there? Hypotenuse. So I have adjacent. All about what there? Hypotenuse. Please, what's my adjacent? If I'm considering 30 degree, please, so consider 30 degree. What's my adjacent? That because of this man here, Abi. That becomes root 3. So let's just put the value straightforward. Root 3 all over. What's the hypotenuse? Always constant, Abi. That's 2. So the value for cos 30 degrees, without calculating, we give what there? Root 3 over 2. All right. This becomes the second expression you need to note. All right, one last one. This sine cos, Abi. Let's say what there? Tan. For tan 30 degrees, please. What's the expression for tan? That because what there? Opposite over what there? Adjacent. Am I correct? Adjacent, please. So it's now equal in value to considering angle 30 again, please. What's my opposite? That's what? 1. So I have 1 here. All over. What's my adjacent, please? That's root 3, Abi. So root 3. So in mathematics, it's not proper for your denominator to be a square root. Hence, I what? Rationalize. So if I rationalize this one, I'll be having what there? Root 3 over 3. So I'm saying that tan 30 degree is equal to what? Root 3 over 3. If you say 1 over root 3, it's still correct. But the idea is that in math, generally, it's not proper to leave our answer as a square root for the denominator. So the idea is that you rationalize. After rationalizing 1 over root 3, I'll have root 3 over 3, as you can see. This is when we consider angle 30. Let's consider angle what there? Angle 60 degree, and let's see what we get. So consider what there? 60 degrees. What do we get? Let's start with sine, please. For sine 60, what's sine? That's what there. Opposite over what there? Hypotenuse. So I have opposite all over hypotenuse. Please, if I'm considering angle 60, this becomes what there? My opposite, right? So I have root 3. So root 3 all over, what's the hypotenuse? That's 2. I have root 3 over 2. So it means that sine 60. So at this point, note that tan 30 degrees is equal to what? Root 3 over 3. So this becomes under 30. For 60 now, I have that sine 60 degree now is equal to what? Root 3 over 2. Note this man. Very important, please. Alright, I have this one here. Proceeding from here, I've considered sine. Let's consider what there? Cos. So I have cos 60 degrees. That will give what there? Adjacent over what there? Hypotenuse. Please help me check, please. What's my adjacent? If I'm considering angle 60, please. If I'm considering angle 60, what's adjacent? That's 1, Abby. I have 1 all over. What's the hypotenuse, please? 2, always constant. So I'm saying that cos 60 is what there? Half 1 over 2. I have this one. Finally, let's do tan, please. For tan, what there? Tan 60 degrees. What's tan expression? Is what? Opposite of what? Adjacent. So I have opposite over what there? Adjacent. Please check my opposite. What's the opposite there, please? Consider angle 60. What's the opposite, please? Root 3, right? So I have root 3 all over. What's the adjacent, please? Are you sure? I have 1. So root 3 over 1 is what? Is still what there? Root 3. So I'm saying that the tan 60 degree is equal to what? Root 3. So note this expression. We use all this expression in our solvings in our next class, right? So this for 30, 60. Let's derive the 45 degree concept. Welcome back. Let's consider angle 45 degrees and end this concept. So consider angle 45 degree, 45 degrees, please. What's the concept? Now, to derive the expression of 30 and 60, we need to draw out a equilateral triangle, or perhaps an equilateral triangle, which I have done, which I used to derive this one. But to derive 45 degree, I'll draw what? A square, which all sides are what? Are of what? 1 unit. So to derive the expression for this one, I'll draw out what? A square. Let's assume this is my square, please. Call this here point A, B, C, and D. Alright, from here now, look up, please. We said make all sides 1 unit, 1 unit, 1 unit, and 1 unit. Right? So at this point there, draw a diagonal line. Alright, I have this one as my diagonal line here. So it means that this has been divided into 2. And if I divide a square into diagonal concept, I'll have 2 right angle triangle. So the idea is that I'll pick one out of these 2. So let me just pick this down one. Picking this one like this, I'll have something of this nature. Observe, something of this nature. This is my point B. Here is what? Point D. This one is 1. All right. Observe, please. Observe, please. Here is 90. Here is 90. Here is 90. Here is 90. Half of 90 is we got there 45 degrees. Let's say here becomes my 45 degrees. Here becomes my 1. What's the value here? So since we don't know the value here, we still apply the concept of what's it called, Pythagoras theorem to get this part here, right? So let's do that, please. Considering Pythagoras theorem here to get this part, so I'll have that, let's call it z. So I'll have that z squared is equal to what? 1 squared plus 1 squared. I'll have that z squared is equal to what? 1 plus 1. Z squared is equal to what? 2. Take this square out there. Z is what? Root 2. So I'll put root 2 as being equal to z. Now let's start with our derivation. Let's start for sine, cos, and tan. So let's find the sine of 45 degrees, please. Sine, let's start with sine 45 degrees. What's sine expression? That's what? Opposite of what? Over what there? Hypotenuse. So have opposite here. Over what there? Hypotenuse. Check, please. If I'm considering 45 degrees, what's my opposite? That's 1, Abby. So I have 1 all over. Hypotenuse is what? Root 2. I'll have root 2. We just said that it's not proper for root to be down as denominator. So what? Rationalize. So I'll have my answer as being equal to what? Root 2 over 2. So the value for sine 45 degree is what? Root 2 all over 2. I have this one here. All right. From this point here, proceeding, let's move to cos. Let's get the value for cos 45 degree. What's the expression of cos? Cos is what? Adjacent over what? Hypotenuse. So I have adjacent over what? Hypotenuse. All right, from here, what's my adjacent, please? Check diagram. What is adjacent here? That's 1 over what there? Hypotenuse is what? Root 2. This man here and this one similar, so I'll have my answer as root 2 over 2. So I'm saying that the cos 45 is equal to what? Root 2 over 2, as we had just now. All right, this for cos 45 degrees. Let's get for tan 45 degrees, please. For tan 45 degrees, what do I have? What's the expression of tan? Opposite are what? Adjacent. So I have opposite over what there? Adjacent. Please, what's my opposite, please? Check. What's opposite, please? That's 1. And this is what? 1. So what's the expression? Tan 45 degrees. We give what there? We give 1. This becomes the expression you have to note when it comes to the concept of trigonometry ratios of angle. So in summary of what we have discussed earlier, if you don't know how to derive all what we have just derived now, that's not a problem, that's not an issue. They can't ask you to start deriving the exam. All right, what they want you to note is what is those value. All right, it's reading from sin 30, cos 30, tan 30. By the way, cos 30 is so call it sin 45, cos 45, and tan 45. That's by the way. And also we have sin 60, cos 60, and tan 60. Just on the value, that's all. So you don't need to start cramming derivation. You don't need derivation. What you need is what? The values, right? So let's summarize the values. So we started from sine, we started from 30 degree. For 30 degree, we said sine 30 is what? 1 over 2. We also said cos 30, we give what there? We give root 3 over 2. And finally, we said tan 30, we give what there? Root 3 over 3. This for 30. Also for 60 degrees, we said that sine 60, we give what there? Root 3 over 2. Next up, we said cos 60 degree, we give 1 over 2. And we said tan 60 degrees, we give what there? We give root 3. Finally, we also said for 45 degrees that sine 45 degrees we give what there? We give that's what, root 2 over 2. That's sine. For cos 45 degrees, that will give about root 2 over 2. Finally, tan 45 degrees we give what there? We give 1. So this becomes the main purpose of this class. Know these things, please. Very important. So this is like the concept behind trigonometry ratios of angle. So see you in the next class. If you're not subscribed to my channel, do what to subscribe, hit the like button, introduce this video to your friends and classmates so they can learn too. See you in the next class. Thanks for watching and welcome to Excellent Link Academy.